All right, welcome to our supplement, complex numbers and radicals. Something you need to review. Not a lot of after our internal classwork here, but something we need to review before we get a little bit more deeply into complex numbers. So we want to talk about terms and definitions of a radical, simplest terms for radicals, and operations with radicals, which we're going to cover in part when we talk about complex numbers. We need to go back and revisit this information with you. All right, so this is radical notation. Radical notation includes some elements to it. So radical notation, I have the radical sign. I have an index. Typically this number is larger, but it's in this pocket here. If there's nothing stated, it's 2, which means it's a square root. This value underneath the radical sign, here's the radical sign, is called the radicand. And then typically a power is placed just to the right of the edge of the top of the radical sign. So I have index, power, radicand, radical sign, and that's all part of radical notation. I can, and we will talk about this later, I can convert this to rational notation. And rational notation would be 7 to the power of 1/2. So 1 is the power. It's not stated here, but it's 1. And then the index is going to be the denominator in your exponent. So numerator is the power, denominator is the index in rational notation. But we're just going to talk about radical notation for today. All right, so if I have a radical here with an index of 4 and a power of 3, then I would rewrite it in rational notation as 7 to the power of 3 over 4. All right, so that's how this works. All right, simplest terms for radicals. Simplest term for radicals, again, so I have my base, and this is in rational notation. I have my power, and then I have the index. So 4 to the power of 3 over 2. This is my base, which is my radicand, power here in radical notation, and index here. All right, so simplest form, and we're going to go through this at a later date when we talk about more specifically complex numbers. Simplest form of a radical is it has no perfect square root or nth roots. We'll talk about nth roots in pre-calculus, but for this class it'll just be perfect squares or perfect squares, perfect square roots. So if I have the square root of 8, I can separate using the properties of radicals into its factors, one of which is a perfect square of 4. I can take the square root of that value and I end up with an integer value. So where I can represent the square root of some value as an integer, then that's the way that I want to represent it. So the square root of 8 is equal to the square root of 4 times the square root of 2. It's 2 root 2. Second is we need to rationalize the denominator, meaning I don't want any radicals in the denominator. We're going to cover this in pre-calculus, or you're going to cover it in pre-calculus. So we're not going to spend a lot of time here. We go through a process called rationalizing the denominator. And then like terms are combined. So like term would be the same base and the same index. In this case, we don't need to worry about the index with square root values because the index is 2. All right, so I have like terms in root 2 and root 2. So 3 root 2 plus 4 root 2 is 7 root 2. But remember, this base of the radicand value has to be the same in order for us to add or subtract. All right, so simplifying radicals our practice. First thing we're going to do is we're going to identify the perfect squares as factors of the radicand. We're going to rewrite the radical, breaking it into its factors if there are perfect squares that are factors of the radicand. So I'm going to rewrite this as the square root of 36 times the square root of 2. And then I'm going to simplify this perfect square that's a factor, by rewriting it as an integer, 6 root 2. All right, simplify radicals practice. Let's see if you can do this along with me. So please take care of these problems. This is not classwork you have to submit, but I would like for you to work along with me. All right, you can pause here. All right, so I'm going to find perfect squares as factors. Square root of 16 times the square root of 6. That's 4 root 6. Square root of 98 is square root of 49 times the square root of 2. Square root of 49 is 7. 7 times root 2. Square root of 128 is equal to the square root of 64 times the square root of 2. That's 8 root 2. We're not going to rationalize the denominator, so I'm just going to move quickly through this. You can look at it if you want. And the last thing is operations with radicals. All right, so adding and subtracting radicals. Remember, it needs to be the same base or radicand value in order to add or subtract. So let's see if you can add or subtract these. Please pause and come back. All right, so you end up with 6 root 2 minus 7 root 3. Right, I have 3 plus 7 is 10, minus 4 is 6 root 2 minus 7 root 3. These radicand values are different, so I cannot add or subtract them. I can multiply them and combine them, but I cannot add or subtract unless they're like terms, which means they need to have that same radicand or base value. Second one, I have 2 root 3 minus 6 root 3 is minus 4 root 3. 3 root 2 plus 7 root 2 is 10 root 2. And then lastly, I have two like terms. Negative 2 root 7 plus 7 root 7 is 5 root 7 plus 6 root 2. All right, moving on. Didn't we just do this? Oh, we're multiplying. Okay, so now we're going to multiply these together. So multiplication now, we're going to multiply the integer values and the radicand value separately and then simplify from there. So let's see if you can do this, if you remember how to do this. And I'm actually going to do this for you. All right, so 3 root 2 times 7 root 2 is 21 times root 4. 21 times root 4 is the same as 21 times 2, which is 42. And then I have 4 root 2 times 7 root 3, which is 28 times root 6. So this is 42 times 28 root 6. And if I do my calculations correctly, it's 1,176. At least if I typed in the correct numbers into the calculator, times the square root of 6. Square root of 6 has no perfect square roots as factors, so I just leave it as this. There's no more simplification. Next one, 2 root 3 times 3 root 2. Actually, let's do the root 3s and the root 2s together. So this is 21 times 2. Again, 21 times the square root of 4. It's for these two, which is 42 again. And 2 root 3 times 6 root 3 is 12 times 3, which is 36. So I end up with 42 times 36. Which is 1,512. So 6 root 3 times 2 root 3 is equal to 12 times 3, which is equal to 36. Okay, last one, 2 root 7 times 7 root 7 is 14 times 7. 7 and 28 is 98 times 6 root 2. 98 times 6 is 588. This is equal to 588 root 2. Okay, that's it for our quick review of radicals, operations with radicals, and defining simplest terms with radicals. Next step is for us to talk about complex numbers. Thanks for joining.